In this video, we're going to learn about function operations. So you will be given different functions. So this is a function f of x, this is function g of x, and this is function j of x. So basically, whatever operation is being shown here is what you're going to do with the functions above, and then simplify by combining your like terms. So for this first example, we're going to create a new function called h of x, and we're going to make this function by adding our function f of x. So instead of writing f of x, I'm going to write what f of x is equal to. So I'm going to write 2x plus 1, and I'm going to add it, so plus g of x. So this is my f of x, and then g of x is just 5x. You don't have to have these parentheses. I'm just showing that in place of g of x, I'm putting 5x because that's what g of x is equal to. We would definitely need parentheses if this was subtraction, but it's not. So for addition, it just doesn't really change anything. My like terms would be 2x and 5x. So my final answer would be h of x equals 2 plus 5 is 7x plus 1. All right. So looking at the next one, this one is subtraction. So we're going to create a new function h of x, and we're going to take the function g of x, so that's our 5x, and subtract f of x. So this, we need those parentheses. And the reason why we need those parentheses is because we have to distribute this negative to both terms inside the parentheses. So this would be 5x minus 2x minus 1. Okay, and then my final answer for h of x, this new function, combining these like terms, I will have 3x minus 1. Multiplication. So for this one, I'm going to do f of x times g of x. So this new function, h of x, will be f of x, so 2x plus 1. So for multiplication, we need these parentheses. G of x is 5x. And so this is my f of x function and my g of x function, and I'm multiplying the two. When I multiply these, I'm going to distribute. If this had more than one term, so if it had 2 terms, we would do FOIL. If there were 3 terms, we'd have to distribute to everything. So distributing 5x, I would have 10x squared plus 5x. And that would be my final answer. We're not trying to factor or anything. We're just doing whatever operations indicated and combining like terms. Okay, next one is division. So f of x, so that means this function will go on top. So we have 2x plus 1, and g of x is 5x. There's my division. That's it. Okay, next one, composition function. So composition function means instead of this being just f of x, so I'm looking to whatever's on the outside here. So I'm looking at my function f, and since x is being replaced by a function, so wherever I see x and f of x, I'm going to replace it with whatever function is in place of the x here. So I have h of x, my new function, and I'm going to write out my f of x function and leave an open space for where the x is. Okay, so whatever is on the outside, so I have f on the outside, so look at my f function, and I left an open space wherever I saw x. So this is 2x plus 1, so I have 2 blank plus 1. Okay, so in place of this x, we're going to put this function, g of x, in for x. So wherever I have this space, I'm going to write what g of x is equal to, which is 5x. Okay, so now I just multiply, and that would be 10x plus 1, and that would be a composition function. So composition means you're replacing the x in another function with another function. Okay, this one's a little bit different. So I just start with what's on the outside. So for this new function, I have j on the outside. So I look here, this is my function for j. So I'm going to leave a blank where I see x. So I have blank squared plus x. So that's going to be another blank plus 1. Okay, so for composition, I looked at what was on the outside. J was on the outside. And then this is my function with j. Wherever I saw x, I left a blank. So this is x squared plus x plus 1. So blank squared plus blank plus 1. And I'm going to put in my g function. So that would be 5x. So g would be 5x and then 5x. Okay, so I just put in the blanks, the g function, and now I'm going to evaluate what I have here. So 5x squared would be 25x squared plus 5x, so plus 5x plus 1. And then here I have a number in for x. So I'm not going to leave it as x, but I'm going to plug in 2 in for x. So that's what this 2 instead of x means, is wherever I see x, I'm going to plug in 2. So I first evaluated it with the composition as x, and then I'm going to plug in 2. So this would be 25 2 squared plus 5 times 2 plus 1. Okay, and then order of operations, you would square before you multiply. So 2 squared is 4. 4 times 25 is 100. 5 times 2 is 10 plus 1. So this will come out to be 111. So we have h of x right over here, or right underneath here. So h of x would equal 111 for your final answer for that one. So if you have a number in for x, that means you're plugging a number in for x in the equation. If we have a function in for x, that means we're plugging in that function in the equation. And then everything else, you're just doing whatever operation is indicated. Okay, so that's the first part. The second part is finding the inverse. So when we find the inverse of a function, all we are doing is switching the x and y and then solve for y. Okay, so this is like our y. And so I'm trying to find the inverse of f of x here. So when we write the inverse, we write f of negative 1x. That's just how we write out that it's an inverse, when we do f to the negative 1 of x. Okay, actually before I do that, I'm going to first switch my variables and solve. So I'm going to switch the x and y. So this will be x equals 2y plus 1. So you switch the x and y, and now I'm just solving for y. So I'm going to subtract 1. So I'll have x minus 1 equals 2y, and then divide by 2. So now when I write the answer, the inverse is f of negative 1x. So this just means f inverse of x. Okay, and then I just put this in for my answers, x minus 1 over 2. So the inverse of 2x plus 1 would be x minus 1 divided by 2. So let's look at another one. So this is the same thing as like y. And we have 2x squared plus 5. So I'm switching my x and y. So this will be x equals 2y squared plus 5. And then I'm solving for y. So I'll first subtract 5. So I have x minus 5 equals 2y squared. Okay, so we will need to solve with square roots, but before I do that, I have to divide out this 2. So I'm going to divide by 2. Okay, so I have x minus 5 over 2 equals y squared. Okay, and now that I have my variable raised to the exponent isolated, I can solve by square roots here. So I'm going to take the square root, and that cancels out my square. Okay, so this would be y equals the square root of x minus 5 and the square root of 2. And we do need to rationalize this. So rationalize, remember, means getting rid of the square root in the denominator. So I'm going to multiply by the same thing that's in the denominator, so by root 2. Okay, so my final answer here will be f inverse of x is equal to square root of 2 times square root of 2 is square root of 4, and that's equal to 2. Square root of 4 is just 2, so that got rid of my radical. And this 2, it would be something like 2 times this x minus 5. So I would have to distribute 2 into that expression. So this would be 2x minus 10. And this would be my final answer for that. Okay, so that one had a few more steps because we had to rationalize our denominator and solving with the square roots. Okay, this last one, it's the opposite. Instead of being raised to some whole number exponent, we have a radical. Okay, so again, this is like y, x plus 2. So first thing I want to do is switch out the x and the y. So this is x equals the square root of y plus 2 minus 3. Okay, so first I will add 3 to both sides. This is x plus 3 equals, and it's the square root of y plus 2. And then I'm going to square both sides. Okay, so this is x plus 3 squared equals y plus 2. Now I can't just subtract 2 to the 3 because this is being raised to an exponent. So what I need to do is expand this, and I will need to do FOIL or distribute. So x times x is x squared, 3x plus 3x is 6x, and then plus 9 equals y plus 2. So this is the main step here. We don't distribute the exponent. We have to rewrite it twice and then do FOIL to get this expression. And my last step is just subtracting this 2. So my final answer for g of negative 1x is x squared plus 6x plus 7. And that would be my final answer there. Okay.